Hello everyone, myself Saurabh Maheshwari and I welcome you all to the ongoing lecture series on C programming. And in the previous video we were doing the concept of pointers, and in this video we will do explore further the concept of pointers for various purposes. Till now we have seen that what is the concept of addressing and what is the role of pointers to access the address of various variables. Then we saw how to assign various values or various addresses to the pointers, how to assign values at the locations directly without using the actual variable through pointers, and then assigning the variable value, assigning value of another pointer to a pointer, right? And in this particular video we will see that how to perform arithmetics of pointers. It might look a difficult objective to see that whether pointer can be arithmetic, pointers arithmetic can be done or not, because pointers are not actually integers. Okay, these are addresses. So these stores addresses. So doing arithmetic on addressing is a different situation that we have to understand how it is processed, right? So any address is arithmetic. Applying arithmetic on address, arithmetic here would be arithmetic that we will apply here would be increment and decrement. Okay, so increment and decrement operator that we can apply over here, and we similarly we can apply addition and subtraction over the addresses. Okay, now applying, what do you mean by applying any arithmetic operator on the addresses, right? Suppose address is 1000, right? 1000 we have seen like in array. Okay, like in array we have contiguous memory allocations, right? So this is a linear array that I have represented here, and this is a contiguous memory allocation, right? So it is 1002. Since it is, I am taking as an integer array, and I will also take a character array, right? I will also take a character array here also. So it is a character type. The addressing would be like continuous, right? Because each element requires only one byte. So that is why it would take 1 byte for per element. So it looks like a continuous memory allocation. Here it is a contiguous memory allocation because every element requires 2 bytes of space. So the next available space is just after storage of the previous element. Okay, so these are the two scenarios of arrays. Okay, now if I do this, that if I have a pointer p, okay, a pointer p which points to this location, and I have a pointer q which points to this location. Okay, now how would we be able to do that? That is declaring this with the help of integer pointer, and declaring the other as the help of character pointer. Okay, these would be the two declarations. I will tell you assignment later, how you are going to do assignment of array variable to the pointer. But right now you just take for example that this p belongs to p points to 1000. It means there is a variable p, okay, and it stores 1000 here, and its own address might be 2000. Here in the another scenario you can have a variable q. This not happen like in the same program, right? Because same addresses cannot be given two different arrays. Okay, so I am taking these as two different scenarios. Okay, now here q is there, and it is also having the address as 1000, and it might have itself stored at 2000, right? So now doing this, if I take this p plus plus, now what happens with this p plus plus? Okay, now p plus plus and semicolon. Now value of p is 1000. Okay, and it is incremented by 1. Okay, p plus plus is incremented by 1, right? Now incrementing by 1 in the normal mathematics, it appears as to be 1000 plus 1 as 1001. 1. Okay, but in the concept of addressing, okay, in the concept of addressing, it increment by 1 means next contiguous memory location, next contiguous memory location, right? So in case of integer array, if you do p plus plus, instead of incrementing, that is 1000 by 1, instead of going to 1001, it would go directly to 1002, because you can see that the next element is available at 1002, so it will go to 1002. Now if you again increment it, either pre increment or post increment p plus plus, it will not go to 1003, it will directly go to 1004, because the next element is available to 1004. This is the important concept of pointer arithmetic, that is increment. And decrement will happen like this only. If you have value of p like this and you do p minus minus, okay, so p minus minus will go to 1002, not 1003. But in case of characters, okay, I have taken one more example in the form of character. So it is here it would look like this go in the continuous memory. Like if initially q is equals to 1000, this is a thing that I am printing, it is not a thing that is to be assigned, right? So q value is 1000. Okay, now if you do q plus plus, okay, if you do q plus plus, then this 1000 will become 1000 will be incremented by 1, so it will become 1001. So there may be a confusion that here went to 1002, but here it incremented to 1001 only. Why? Because here the next contiguous memory location is 1001. For characters, in case of characters, the element require only one byte, so the next byte is used for the next element, right? So the incrementing of the address would be one byte only, because it is a character pointer. Okay, incrementing will depend on the actual variable size, okay, actual data type size of the particular type of the particular pointer variable. Okay, so if pointer type is float, okay, so the increment or decrement would be for the 4 bytes each. Okay, it will, if you want to increment value, then the address would be incremented by 4 bytes to reach to the next element, right? And if it is a decrement operator, then the current address would be decremented by 4 bytes, okay, to reach to the previous element. So in this way you can this is one of the application that we will use to scan an array without help of any other without help of indexes, with the help of pointer only. Okay, now there are some advantages and disadvantages also available for pointers. Okay, obviously advantages you can count down, that you can a access a variable value without accessing name of variable, fine, like we did before. Okay, like we did before, that here you can see that uh, how we accessed value of a without using. Okay, now we accessed here value of p, value of a, without using a variable, right? And we also changed the value of a. Okay, here we also change the value of a without even accessing a. Okay, in this program I have never assigned any value to a. Okay, and even after that we are able to change and even access the value of a. So this is the most important advantage and prime application of array, of pointers, right? Now this also becomes a disadvantage. Like you have to understand that suppose you have a variable a, which stores, which has an address and which stores a code as 0 or 1, which stores a code as 0 or 1, such that if it is 0, then the missile will not launch, and if it is 1, missile will launch. Okay, now suppose a virus is installed. Okay, a virus is installed in the computer. A virus is installed in the computer, and it has a pointer, and it is able to know the address of variable A. So this A is a logged variable. Suppose this A is a logged variable, and it cannot be it can only be accessed by authentication, right? You can have to give a proper password and everything, and then only you can get the authentication and access this variable A. Okay, but with the help of this pointer, okay, and this would this after this authentication, you would run this statement A equals to 1, then missile will get launched. This is the normal procedure when you do when you properly follow authentication system. Now this virus, what it can do, it can have the access of the variable. Okay, access of the variable address, and not the actual variable. Okay, so anywhere it will not perform A equals to 1 statement, but what it can do, if it has address of A, then it would simply execute this statement, pointer p equals to 1. So as it does p equals to 1, and since it is pointing to this, so this 0 will be changed to 1, and as it changed to 1, it will execute a command for the missile to get launched. Okay, so this is the problem which can be faced with the pointers here. Here you have to see that your addresses can be accessed out of the blocks. Okay, yeah, till now we have seen that a variable is only accessible between the scope, right? There is a scope of each variable. Okay, and in it is accessible in this scope only. Okay, but scope only, and this scope is generally stored in a same memory block. Okay, the memory in the actual memory is divided into some blocks. Okay, this is block 1, this is block 2, this is block 3, this is block 4. Suppose there are 4 blocks. So if this particular scope is in first block, and this is virus scope of virus, and it is another block, right? But if directly if a variable A is there, this A cannot be accessed here. Okay, this cannot happen. If there is a variable which is declared in this scope, it is not accessible in this scope, because it is a local variable to this particular scope, and this is local variable to this particular scope. So but if you use a pointer, okay, and you have anyways you have this pointer variable, and it has address of A, which is of this particular block, right? This is doable, because this P is variable of this particular scope, but the address that it has, the value in the form of address it has, is from this block. So this block might be having address from 1000 to 1005, and this block has address from 2000 to 2010, suppose. So these blocks are two independent blocks, but the pointer p can have value of A and can point to an address of particular p. P can have address of, suppose, the other block. So this address can be accessed by this P, and in this way this virus scope can access any variable value, not the variable. I'm not saying that it can access the variable. Okay, it can access directly the memory locations where the variable is stored. Okay, so this becomes a most important disadvantage, that memory accessing a variable without accessing a variable value without accessing name of variable, this is an advantage and disadvantage both. Okay, advantages are there, yes, you don't require variables and you can directly access memory in different scopes and others for other applications. But the most dangerous application is this particular access if not handled properly. Okay, so other the malicious programs can access value of important variables. Okay, malicious malicious codes can access values of variables from different scopes and blocks. So this is disadvantage of pointers. Okay, now let us see the concept of pointers to array. Okay, so suppose you have a array like this: a5 equals to 3, 4, 2, 1 and 6. Suppose this is your array, and you want to have a pointer. So instead of accessing this array through variables or index, we can have an alternative method to access this array with the help of pointer. So what I need to do, I need to suppose I have a pointer p, and this is the way it can be declared. It has to be of the same data type that you have to see. Okay, and since a pointer stores an address, so which address of the array, because array has multiple elements, right? So this array is stored in memory like this. Okay, and it has 3, 4, 2, 1, 6 like this, and suppose it starts from 1000, its name is a. Okay, and this is 1002, 1004, 1006, 1008. Okay, so this is how it is stored. Fine. Now I want to have a pointer p. Okay, and which is having storage at suppose 2000, and this pointer p needs to point to a. Okay, so how I will assign this: p equals to a. Now see this, as you know, name of address is its base address, name of array is its base address, right? Is its base address. Fine. So you not need to write this p equals to ampersand a. This is not required, because a itself, the name of array itself, denotes the base address. Okay, so in the case of array, okay, the pointer variable can be assigned directly with the help of the name of the variable. Okay, now as soon as I execute this statement, what happens: the array address, the base address of array, which was 1000, comes to this p. Okay, now p start pointing to the first element of the array. Okay, now suppose I do this. Okay, I do this printf percent d, and I print pointer p. Okay, now what does it mean? Printing pointer p means I want to print value at address in p. Now what is address in p? Address in p is 1000, and what is the value at 1000 is 3. Okay, at 1000 means the complete memory location, right? 1000 and 1001, what is the value at that place is 3. So this will get printed as 3, right? Now if I do this p plus plus, okay, now p plus plus, what does it mean? P plus plus, p is a address variable, it is a pointer variable, so it has some address into it. And if you want to increment it, this increment would not be a normal increment, but it would lead to a contiguous memory. Okay, it lead to a contiguous memory, so it would change 1000 to not 1001 but as 1002. Now this, as soon as this 1000 is incremented to 1002, this pointer, instead of here, it starts pointing to this place, right? If we increment this p more, okay, or I first print this pointer p now, executing the same statement after running p plus plus would print value 4, because now this p has now pointing to is now pointing to this second element, which is 4. If I do p plus plus more, okay, and then print again, right, pointer p, okay, so this will print 2, because as soon as we increment it more, this will go to the next contiguous memory location, and it would be 1004. So it will start pointing to this variable, so it will print 2. So this is the way how we can scan any array with the help of pointer variable. Okay, so what you have to do, you have to just take you have to just assign the base address to the pointer variable, and it starts pointing to the base address. Then you can increment or decrement, okay, increment or decrement the pointer variable to move forward or backward in the array. Okay, so to access any element in the forward direction, you can do p plus plus, and to move in the reverse direction, you can decrement the pointer p minus minus, or so that you can uh, access it. Okay, now is there any method to access a pointer, access a element directly, right? So here you can see that the initial value of p was 1000, right? And when you increment it one first time, it becomes 1000 plus 2, right? It becomes 1000 plus 2, okay, and it is simply 1000 plus 1 increment. Okay, it is like this, 1000 plus increment, okay, the increment by 1. Okay, and if I want to access any variable directly, so what I have to do is simply suppose I want to print this, print f. Okay, I will write over here, print f percent d, percent d. Okay, and in this percent d, I want to print this a2. Okay, and if this a2 can be directly printed without incrementing it the way like this, p plus 2. Okay, the index that you want to print, the index that you want to access, you have to take it in this as an increment. Okay, now pointer p plus 2, p plus 2 means p initially is the base address, p plus 1 is the base plus 1, that is the, this was the 0 index. Okay, now this is 1 index. Now p plus 2, it means base plus 2, that is second index. So p plus 2 is the second index, and which is this. So you can write this, you can use this general formula, that to access any variable ai, you can use directly pointer p plus I. So this is the method to access directly any variable. Okay, and this is also helpful for various programming purposes. Okay, now let us understand with the help of one example. So we take example as summation of all digits or elements of an array, right? Elements of array, right? So for this, you have an integer array 5, suppose I have it, and I have the variables as the values as these. Okay, now what the logic that I want is to sum all the elements, okay, and print a sum. Okay, so I would also take a variable that is sum, and I will initialize it with 0. Now see it carefully, that I need to know, since it is an integer variable, So I need to know the value of n to which the loop will work. Okay, it is a requirement for integer and float because you don't know the end of the array, so you have to know this n. Okay, now I will use this I equals to 0, I is less than n, and I plus plus. Okay, I am going to scan this particular I am going to scan this particular uh, but before that I need to assign before that I need to assign a pointer p equals to a. Since it is a declaration statement, so I can I'm not using p equals to a, but I can write here pointer p equals to a. So what happens, this p starts pointing to a, or this p starts pointing to the first element of this array. Okay, now I will not access the array with the help of this I index. Okay, I am using this I only as a counting variable, not as a index variable, right? So I will simply write sum equals to sum plus pointer p. Okay, sum equals to sum plus pointer p, and just after this I will do p plus plus. Okay, and by the end of this I can print sum. Okay, and this sum would be 3 plus 4 plus 2 plus 1 plus 6, and this would give me some answer which is a required value. Now let us understand this. For I equals to 0, this I loop is only a counting loop, not index. Okay, not index. In normal logic we would have done like this: sum equals to sum plus a I. Okay, now instead of accessing this like this, we have accessed it like this: p. Okay, pointer p plus plus. Okay, now to print this array, है ना? So the problem, if you want to print this array, okay, now sum we have got like this, and if we want to print this array with the help of p, then this p you have incremented. You assigned the p to the base address, but due to increment, what you have done, you have incremented p, and p has reached to the last. Okay, p has reached to the last. So in this way, if you want to print the array with the help of p, you will not be able to print, because p would start printing from here, and the array has already finished till here. So you have to reset p here. So here you have to do either like this: p equals to a. Here, this statement you have to run again, because you want to bring p at the beginning again. Or the alternative method that you can use is for to take this summation is the counting loop is as it is. Okay, and in this counting loop, what you can do, you can sum equals to sum plus pointer p plus I. Okay, now in this way you have not actually incremented p. Okay, you have not actually incremented p, but you have directly accessed this p, access the element of the array with help of addition in the p, but not actual increment of the p. So this is an alternative method to access, because you do with the help of increment of p, then for to access the array again you have to reset the p. Okay, and if you are not doing like this, if you are doing in this form, you can directly access any element with incrementing I to it. Okay, so this is how pointers arrays are accessed with the help of pointers. This is all for this video, and we will do further exploration in pointers in upcoming video. Thank you.